Again, for the question over the other side then, this is something called congruent triangles. And for me, these 2 marks, they're not the end of the world if you don't get them. It's not, if you came out of the exam saying, oh, we didn't get the thing on congruent triangles, I'm not going to be too devastated. We probably need to do a bit of a lesson where we just recap what these things are. Basically, a congruent triangle, so if I drew this triangle here, and I told you the measurements were 3, 4 and 5, and then I gave you another triangle here, and I told you these were also 3, 4 and 5, if I could physically pick this triangle up and plonk it onto the other one, then it would be what we call congruent, okay? So the definition is all sides and all angles are the same, okay? So could you write that down by congruent? Say all sides and all angles are the same. But what I don't need to do, I don't actually need to know every single piece of information to see if something is congruent. Okay? If I'm given 3 pieces of information, I can then tell you if it's congruent just by knowing, by definition, the rest of them have to be true as well, if you have 3 pieces of information. Option 1, when it says the triangles are not right angle triangles, it says in both triangles, if one length is 3.4 and the other length is 6.2, what other extra piece of information is needed to know if these triangles are congruent? Well, if I've got 2 sides, if I knew its third side, so the other side, the other, in brackets, missing side, if I told you the other side was like 10 centimetres, then they'd have all the same sides, and by definition in the triangle, if they have all the same sides, they do have all the same angles. Okay? And the other one we'd have to know is what we call an SAS. Can you remember creating these in like year 8, year 9-ish, so maybe even year 7, SAS triangles? Side, angle, side, brilliant. But it's really side, included angle, and then another side, okay? Like I said, I'm not too worried about that one at the moment. We will probably, well I say we will actually look at doing that in lessons after this, okay? Where do you want to jump into?
Where are we on now?
Question 8?
Yeah.
Do you want to jump in here? We're going to stop when we think it's worth stopping. So, like for instance, like question 15 is pretty nasty. It's a good idea to stop there and focus on things that are important. Okay, I'm going to give you a break from my dulcet baritone voice, and we're going to swap in Mr. Jones for a few questions, okay?
Okay. OCD. First thing, when you have to factorize a quadratic, okay, you know it's quadratic because you've got an x squared, okay? If you've got a number in front of the x squared that you can see, okay, then what you need to do is do it in a specific way. It's called the AC method. Basically what you're doing is you're multiplying these 2 numbers together as your first step. So our first step is to multiply 6 times minus 25 together. Okay. That gives you calculator paper, so by all means grab a calculator and find out if we use it that way. Now what we're trying to do now is to find 2 numbers which times to equal minus 150, but add to equal this number in the middle. Because that's negative, we know when you're multiplying two numbers together and the answer is negative, you know one's plus and one's minus. So what we're really looking here is two numbers times together to make minus 150. One was positive, one was negative. When you add them together, they'll make an answer of 5, but it's positive 5. So we know one's positive, one's negative. We know because that's positive, the smallest number is going to be negative. So what we're really doing is looking for two numbers, multiply and make 150, but got a difference of 5. So the numbers I've got are 15 and, sorry, let's try that again. Lost my head. So 15 and minus 10 and 15 and minus 10. So 15 times minus 10 is minus 150 and 15 take away 10 equals 5. Okay? So what you do now is because we know the 5 equals 15 take away 10, we can change that 5x in the middle to plus 15x minus 10x minus 25. The next step we do now is we split down the middle and we factorize both halves. So 6x squared and 15x. Look at the numbers first. Biggest number we can divide 6 and 15 by is 3. That can give us x times x, and that can give us an x. So they can both be divided by x as well, so that can go outside as well. Then you say 3 times what is 6? So 2. X times what is x squared? X. 3 times what is 15? 5, and the x is already there. Then this side now we've got minus 10 and minus 25. The highest common factor of minus 10 and minus 25 is minus 5. So now what we do is we think minus 5 times what is minus 10x. So minus 5 times 2 is minus 10. And to get the x, we put that in as well. And then we say minus 5 times what is minus 25. That'll be 5. Just as a check these two brackets are equal. And then what we do, the first bracket then is the number in front of the brackets, 3x minus 5. And the next bracket is 2x, add 5. Okay, if you've got time in the exam, you can try and expand it. Okay. Just to check it goes back to what it is. Alright.
Guys, it doesn't matter which bracket comes first. If you put the numbers the other way around in the middle, your bracket's going to be the other way around, it makes no difference. Okay, you're going to get the same answer either way.
Okay. Okay, this next one. Did a lot of this before Christmas. Okay. It's algebraic fractions. The idea is you go as far as you can on this question. Okay, everyone can get to a certain point. First thing you do is upside down on your board. And what you do, in this bit, you multiply everything that's linked together. So here, this 2 and that top number there is linked together. So we'll put 2, open brackets, 8x plus 1. Take away, because we've got take away. And then 3 times 4x, add 7. Okay, so what I've done is I've multiplied this bit by the 2. Because I'm multiplying all of this top, I've got to put in brackets. And because I'm multiplying all of this top bit by the 3, again I'm putting in brackets. And the minus, the take away, comes from that negative I take away in the middle there. Okay? And at the bottom, denominator, these two link together, and 3 and the 2. So 3 times 2. We'll not do anything with this side yet, so we'll leave it as equals a half.
How many marks will that fit, sir, do you think? Certainly 1.
At least 1. I think when you expand them as well, then you get your 2 marks. Yeah. So that's what I mean by do what you can. To get to this point, just showing some, you get to a certain point, and then if you can expand it, you go a little bit further. Okay, so I think everyone in here is capable of getting to this point and then expanding it as well. Because we've all expanded brackets. So we do 2 times 8x is 16x. Sorry. 2 times 1 is 2. Minus 3 times 4x is minus 12x. And minus 3 times 7 is minus 21. Alright, I times everything here by that 2. When you're adding fractions, one method of adding fractions is to use this method. Okay?
So basically, what I tried to do there is just highlight on the board that you multiply those bits there, so you cross multiply, and those ones there. So that 3 has gone up to there, times all of that, and that 2 has come up to here. Okay, and that's like a really nice shortcut. There's other ways to do it.
Oh, yeah.
Remember, like one of the methods. Well, remember one of the methods when you're doing adding fractions. Okay, so one method of doing that is doing this method, where we do 2 times 7, add 3 times 4 over 3 times 7, which gives us 14, add 12 over 21. Then you add the top together, so it gives us 26 over 21. That's what we're doing. We just got out of it.
There's definitely longer ways of doing it. This way is a really nice shortcut. And if you can use that number method, it makes this.
So tick it back to what you would do if you were just adding fractions. Alright, the bottom one then, the denominator is just 3 times 2 is 6, and still equals half. We haven't touched that. Okay? Then what we can do then is we simplify the top. 16x take away 12x is 4x. 2 add minus 21 is minus 19. Again, don't try and do it in your head if you're not sure. Put 2 take away 21. Just make sure you don't make a mistake. Over 6 equals a half. Okay? Now what we want to do is put all the numbers over this side and leave everything else over that side. So first thing to stop on this is that divided by 6. If we multiply all this side by 6, we do the same to the other side. That loses the divide by 6 here. A half times 6 is 3. So we have 4x minus 19 equals 3. At this step then, hopefully everyone's okay with seeing minus 19. We get rid of that by adding 19 to both sides. So 4x equals 22. Divide by 4. Divide by 4, doesn't matter, we're going over a bit. When you divide it by 4, again, got a calculator, use it, okay? So it'll be 5.5. Okay. So don't be afraid of the fact there might be some numbers where a decimal, especially on a calculator paper. Sometimes you can do it in your head, but you've got a calculator, just try using it, okay? Sorry, do you want to keep it there so you can copy it? What do you make this one? I don't like this one. But in big numbers, you've got a calculator, haven't you? Don't be scared of numbers. Alright. Alright, this question. Miss? Nick, can you do me a favour? Can you go down to the office and say how you left? Okay. Come on, okay. Taylor, Taylor. Taylor. Headshot there. Okay, this question. It says, small boat is 4.5 kilometres from a lighthouse. The bearing of the small boat from the lighthouse is 0.92. Remember what we said about bearings? Clockwise, from north, and 3 digits. Excellent. So we got a lighthouse. Not a very convincing lighthouse, but it's a lighthouse, okay? That lighthouse then, if north is all go in this direction, okay? Stranger. Then it's 90 degrees from north. So that means we're going to be going in this direction. So 90 degrees from north is there. So the boat from the lighthouse is 90 degrees. So here is my boat. Then it says the boat, Mason, please. Then it says the boat is 3.2 kilometres north of a tanker. So if it's north of a tanker, it means the tanker is underneath it. So this length here is 4.5. That length here is 3.2. Doesn't have to be accurate, I'm just sketching it, okay? And once you've done that, hopefully you can see you've got a right angle triangle. And what it's asking us to do is to take the distance between the tanker and the lighthouse. If we've got a triangle, a right angle triangle.
Message somebody left
Yeah.
with permission?
I guess have a think about how you're going to work out that missing side there.
Okay, so we've got a right angle triangle. We've got a right angle triangle, and we're trying to find a length. It's called length x. Oh no. Okay, this is something we're trying to find. We're trying to find this distance here. We've got a right angle triangle, there's no angles involved, and you're trying to find a distance. Pythagoras, what is it? So we're going to use Pythagoras. Alright. Pythagoras theorem is the longest side squared is the other two sides squared added together. Do we know the longest side? No, we don't.
Hypotenuse.
We don't. We're trying to find the hypotenuse. Well done, Sam. Okay, so we're trying to find the hypotenuse. So we can say x squared equals the other two sides squared added together. Put that into calculator.
So if you have to draw it, just
Draw it, don't draw to scale, just draw it, sketch it out. You get a mark, part of the workings out is the drawing, so you get a mark for the sketching it out. So 2.2. Oh, and then you then you go square root it. Okay. Add 4.5 squared equals. Okay, and then what you do, so you know x squared is 30.49, so x equals the square root of 30.49. So x equals 5.52. Doesn't say anything about doing it to certain number of decimal places. Generally, just write down what you can on the screen, okay? And we can say what we're going to as well if we need to, okay? But remember, on a calculator paper, it's always good to write down the numbers as they appear on the screen, okay? So if you wrote this down, and then you think, well, now I want to round it just because I think it looked better rounded, and you mess up the rounding, there's no marks here for rounding. So if you do make a mistake on the rounding, the fact you've got the answer there, no matter what you've done after it, they'll give you the full marks for it, okay? So always write down what's on the screen. It'll take you 1 second more. It's just good practice to do that. Alright, this one then. Bearing of the lighthouse from the oil tanker. For me, I just like to sketch it out again, so I know what I'm doing. That's 4.5 and that's 3.2. What I wouldn't suggest you do, unless you've got no other option, is I wouldn't use something I've calculated above. Because it could be that you made a mistake. So if you've made a mistake and used your own numbers, they'll give you the marks for it, but what it sometimes ends up with is a much harder calculation if you've made a mistake. Okay? And also it's harder for the person marking it to see if you've made a mistake, so you might lose marks. Okay? So we're trying to find the bearing of the lighthouse from the tanker. So the lighthouse is there, the tanker's there. we're trying to find the bearing. Remember, we're going clockwise from north. We're trying to find this angle here, this bearing here. To find that, what we do is you work out this angle inside, and then because that's a full turn, we subtract that away from 360. So find that angle, so we'll call it theta, and we'll subtract that angle away from 360. We don't know where it is. Good. We don't know where it is, but we've got now a right angle triangle where we've got angles involved. So we use trigonometry. Okay? So, trigonometry. Label the sides. Opposite, hypotenuse, and adjacent. We're going to use SOHCAHTOA. Good.
So I need to do like this.
SOHCAHTOA will be in the exam. However you do it. Remember, we tick what we know. So we know the adjacent, and we know the opposite. The one with 2 ticks, that's what we're going to use. So tan of the angle equals 4.5 divided by 3.2. So you work out on your calculator, 4.5. So 4.5 was the opposite, and the adjacent was 3.2. So that's why 4.5 went on top. That's the opposite. 3.2 is the adjacent. Okay? Gives us that number. So tan equals tan to the minus 1, because we're trying to find the angle, so we've got to use the inverse tan of this number, whatever it is. So do shift and tan. That's what you need. Oh, not this one. No, 1800. No. Alright, so that's the angle. We need the bearing, so we go to 360, take away that number there. So you do 360, take away my last answer, 305 degrees. Okay? So the bearing is 305 degrees. Right, if you're not sure of the bearings bit, okay, when it says bearings, just remember, they're asking you for angles, right? So they're asking you for angles. So if you're not sure about that whole 360 takeaway, it doesn't matter. You're going to get 3 marks for doing the angle correctly. Okay?
How many marks are there? Is your question?
Pardon? Alright, this question now. You've got a rectangle. The question says you've got a rectangle. So draw a rectangle. So do it so you can see it. Well, if the question says you've got a rectangle, draw it so you can see it for yourself. Miles. It says the width of it is x. The length of it is x plus 5. And the area is that. Area of a rectangle. The only thing that makes this look complicated is the x's. Area of a rectangle, you can do for years. Area of a rectangle is base times height. So area of a rectangle, or length times width, base times height, whatever you want to call it, okay? So area of a rectangle is length times width, okay? So what we're going to do then is we're going to put what we know in that diagram. So my length is x plus 5 times x equals my area, 2100. Expand the bracket, so x times everything in there is x squared plus 5x by length times width. This is the rectangle, right? Rectangle, your length times width. Okay, it says length is x, width is up. So same thing. So it's two different ways of remember. Okay. So that times that will equal 2,000 members. Okay. Right, we're going to try and solve it. It's quadratic because we got x squared, and also it says in the question it's a quadratic formula. Use a quadratic formula, so we're going to make it quadratic. How do you solve a quadratic? Well, you've got to make it equal to. Got to make it equal to 0. If you forget that, and it says use quadratic formula, it shows you at the front, quadratic formula says it equals 0. So it says at the front to make it equal to 0. Okay? So we turn to the front, and first of all, we're going to make it equal to 0, sorry. So make it equal to 0, we put everything on this side over there, so it equals 0. Okay? So this stays as it is, that stays as it is, that 2,100 goes over that side, becomes the opposite, and that equals 0. We don't have to do anything now other than use the formula they've given us, and it's on that front page, the formula. So copy the formula down so you've got it in front of you. A, what number is in front of the x squared? What number is in front of the x squared? So there's nothing there. One number is really there if we don't have a number in front of it. We can say 1. Brilliant. So A is 1. B is what? It's the number in front of the x. And C is the number on its own. And if you're not sure what these mean, again, if you look at the front, it tells you in the equation.
Hello, sir. I'm so sorry to interrupt. I'm causing confusion because I thought we were perhaps there's a rule change which I don't know about. Do you mind? Are you able to look at the remote? Sorry.
E12.
What's that?
That's
Next
E12.
door to it. Okay, fine. But normally we're going to be and I've got my 16 because that's the other minuses. Just because of the mixture. Yeah, it's just make it. Yeah.
Let's finish this one first, alright. Alright, let's finish the question off then. Shh. Sorry, like I was saying, if you're not sure what A, B and C is, in the front, it says A is the number in front of the x squared, B is the number in front of the x, and C is on its own. And it's minus 2,100, because there's a negative there, it's minus there, okay? So put this into your calculator, use the fraction button. If you've got a negative, it's really important, on your calculator you use brackets, okay? Okay. So B is 5. Then value of B is 5. B is the number in front of the x. Okay? And that minus B there, all that first minus B does, it flips the sign of whatever B is. So because B is plus 5, in this equation it becomes minus 5. Okay? Use the fraction button. And put it in. C is the number on its own. Okay? Okay. So minus 5 plus square root 5 squared minus, well, put that right, please, mate. 4 times 1 times, put it in brackets, will stop you getting an error, divided by 2 times 1, press equals. And if you get that form come up, press SD, and you get an answer. Equals 43.393899 for now, okay? That plus or minus here means you do this calculation with that as a plus, and then you go back into calculation, or you can type it in again and do it with a takeaway. And that gives us this answer. Okay, remember when we've done this before and we're looking at shapes? Can you have a negative line, a negative length for something? Mason, is it possible to have a positive length? Yes, you can have a negative length. So the answer has got to be this one, because it's impossible to have a negative length. So your answer, and again it says at the top, check back at the top how they want it. In these sort of questions, they'll normally say rounded somehow. That's one of the ways you know it's quadratic formula. So it's 1 decimal place. So we just round it to 1 decimal place. So we round to 43.420p. And it's in centimetres. It doesn't matter if you don't put centimetres, but it is in centimetres. Okay? That's it. Okay, the next one, the next question, you might look at that and think, I'm not sure about this. It's worth having a quick look at it though, because you literally just put in some numbers into an equation. What we've got is a triangle, and they want us to calculate the area of the triangle. Alright, so when you got triangles that aren't right angle triangles, boys, when you got triangles not right angle triangles, okay, what you should think of at the front of the exam, you're given some equations for non-right angle triangles. You've got sine rule, cosine rule, and area of triangle. The question's asking us for area of triangle. So what we're going to do is calculate the area of triangle. The equation we got at the front is area of triangle equals half AB sine C. Well, what's A, what's B, what's C? Use the triangle on the side to help you. So what you've got, A and B are these sides, the little letters of the sides, and the angle in between is the C. So what we're looking for on our triangle is, do we know a side, and an angle in between? If we do, we can work out the area. And if you look back at your question, we've got a side, and an angle in between. So area of triangle is a half AB sine C, or in this above, half the two sides multiplied together times sine of the angle in between them. So put it on your calculator. You can do 0.5 instead of a half if you want. Times 3.4 times 2.7 times sine of 123 gives you this answer here, 3.84. Doesn't say to round it, does it? In the question, there's no mention of rounding, so it doesn't matter. If you want to round it, by all means. That's fine. That's from that one, okay? That's my class. They're normally my class. I mean, okay. So, like I said, you don't need to round it. You don't need units. It's good to do both, though. Okay, but you won't lose marks. You won't lose marks because the question doesn't say do one or the other. In the QWC, they may not have to tell you to round or put it in units. For a normal question, if they don't say it, don't stress about it. Okay. Has anyone done a histogram question? Alright, I'm not going to go through it all then, so only to tell you, when we did histograms, yeah, I love how you look at me in current conversation. So when you're doing histograms, remember the first thing we did when we talked about histograms was to write the frequency is the area. Okay? So for histograms, the area of each block is the frequency. So if they ask you from a histogram question, what is the frequency? All you've got to do is work out the area of each of those blocks and add them together. So the area of this one would be 10 across and 2 up. So that would just be 10 times 2, so 20. Okay? So for histograms, the area of each bar is the frequency. Okay? So if you want to have a go, knowing that, can you have a go at this question? So knowing that the area of each block and its frequency, it said we spend a total time of 60 minutes or less. So there's your 60 minutes or less. What we want is the area of each one of those bars below 60.
Zero is that. Measuring we have to get
yeah, and then you add them all together. So between 0 and 60, add all those areas there.
No, I never meant it. I never meant the last 6. Yours all right. And then there's a sink in the middle. All sides are so there's no shit.
collateral triangles. All sides.
Okay, oh, you can see that. Put them in. So that's 20, 40, 60, 100, 80, 100. So it's 400. Yeah. I said that's the last question. We can't be that explanation. Alright then. Be careful. Shh. Be careful you pick the right one. I think the biggest mistake on this one is, boys, oh, I know you're not doing this. On this question, they had two histograms. They had this one, then the other one, and then the question there, we had to look at the first histogram. And I think people who did this question, they would have accidentally worked out on this one above it. I say people, I did when I first looked at it. Okay? So make sure you do the right one, okay? Okay, quickly to go through these ones. Not going to spend too much time on it. Explain why it's not possible to use histogram to calculate how many telephone calls were made. Shh. Why isn't it possible to use a histogram to say how many telephone calls were made? It's because does it talk about how many telephone calls were made? It just says how much time. Okay? It says how many times each office worker spent on the phone. Not how many times each phone call lasted. It's how much time each office worker spent on the phone. So we don't know how many phone calls were made. Amber. When Meg comes back, okay? And then the next one, I go through this one because it is so you can just look at it quickly. Will. Why can't you calculate exactly how many office workers spent longer than 130 minutes on the 2nd of September on the phone? 2nd of September is this graph. 130 minutes is here. Because it's in the middle of a bar, we don't know everyone between 120 and 140 is everyone in there. But of that between 120 and 140, they could all have been 121, they could all have been 122, they could all have been 130. We don't know. So because it's group data, we don't know. Okay? So we don't know exactly because it is grouped. So we don't know exactly. We could take a guess. If they ask you to guess, what you do is you put a line to the middle of it, but it's still an estimate. It's only an estimate. Okay, move on to the next one. What? So there?
We only know how long the calls will not have many.
Oh, not how many. Sorry, bad writing.
How many?
We only know how long the calls were in total.
Comma.
In total,
Thank you very much.
not how many. I'm very sorry, Mr. Howells. I put a full stop there as well. Oh, and a full stop there as well. I'm very sorry. And it should be starting with.
I was going to say capital F on there. I'm not going to drink it, sorry.
That's okay. You're just judging quiet at the back. We only know how long the calls were in total, not how many there were.
Yes.
Yeah. When she comes back. Okay. And I'm moving off bad language now because I'm getting self-conscious. Alright, this question. The only thing that makes this question a little bit, of a highest level than other ones like this is that normally they give you the table, don't they? And you have to work out two of the missing values and then draw it. But in this, they've given you no table at all. So what you need to do for this question is draw that table out yourself. So it says between -2 and -3. What I would do is I wouldn't just pick 3 values. When it's a curve, you pick as many values as you can. Okay? So instead of doing this bit by bit, what I've done, being lazy, I drew a table out with a calculator. And what you did is you put the x values from -2 to 3. And on your calculator, I'll do the first couple just so you know what we're doing. We've got, the equation is 6 plus x minus x squared. So what you do in your calculator, you do 6 plus, and you substitute x for this number. Remember, if we've got negatives, do it with brackets. Press equals. Page 20, Sam. And no, we're going to stop now. Okay, so we worked this out, changing these numbers. Okay, right, remember, when we're drawing an x squared graph, if the x squared, the value of x squared, is positive, if someone's positive, then they're happy. If the value of x squared is negative, if someone's negative, then they're unhappy, aren't they? So if someone's unhappy, then they're going to have an unhappy face. So that's what your graph is going to sort of look like. Plot the points. One thing to note though, at the top we go from that number to that number. What you don't do is you don't get to that point and do a straight line. You've got to realise it does curve round and come down.
Can I jump in very quickly soon? So it goes back to we looked at the start. If you look at the equation here right at the start, it says y equals 6 plus x minus x squared. What I did earlier was I changed the x's into open brackets. We'll try and write it just underneath. So y equals 6 plus open brackets minus open brackets squared. So when x is minus 2, when I pop it into my calculator, can you see we've already got the brackets in there? It will deal with any of the bid mass that your calculator could get confused on, okay? So that's how it was 0, and that's how you should then change it in your calculator by pressing the replay button to then move along, okay? So that's how I'd recommend that you put that in, okay?
How many marks do you want us to get on the first paper?
First paper.
On first paper, this paper. 20, 20.
27.
I've got 24.
Let's mark it. We've got 2 full days now. Okay. Little top of 10 now. Alright. All I'm going to do now, the next question only. Okay. The next question says, where does 6 plus x, and I'll put it up now, minus x squared equals 0. So the next one is saying, where does that graph equal 0? What's the values of x to make that graph equal 0? It's by there, and it's by there. So the next bit over here, okay, is just looking at x is minus 2 and x is 3. So all you do is x is minus 2 and x is 3. Okay, and I'll do for this paper.
We have like